Assalamualaikum warahmatullahi wabarakatuh. Today our group will be presenting about food and non-food industry and compare between them.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Roslan, and our group choose to present on the soap manufacturing process. Okay, what is soap? Soap in general is a product from the reaction of fatty acid and alkali. Fatty acid were obtained from fats or oil, which also known as triglycerides, from animals and plants. Soap production process were divided into three parts. First is saponification of oils. Second one is neutralization of fatty acids, and the last one is saponification of methyl esters. What's the difference between these three processes? Okay, the first one is saponification of oils. Okay, saponification basically is a chemical reaction provoked by mixing a fat or oil with a strong base. This reaction creates two elements, which is glycerin and soap. Okay, the next one is neutralization of fatty acids. Neutralization in general is the process of removing free fatty acids from crude oils by using caustic soda or lime. And the last one is saponification of methyl ester. Saponification of methyl esters is a technique commonly used to remove fatty acid methyl ester from a complex organic mixture. So that's the difference between these three process. Okay, so for the methodology and equipment in soap manufacturing, okay, we can see the first step is mix base soap and additive with its required quantities in a primary blend for 4 to 6 minutes using scroll type per mixer. The name of the equipment, which is also known as a mixer, called amalgamator. So the next step is the mixture then pass through a series of rollers to homogenize it to produce a thin sheet of soap. So in the second step, basically the mixture of mixed base soap and additive will pass through to a reactor, which also known as roll mill. Roll mill is a reactor. The third step is the homogenized soap were compressed using a large worm screw, extruded or plodder. A single large continuous bar of soap produced, and the dimension was adjusted to fit final product with minimal waste. The equipment that were used is plodding or extruder. This is where the homogenized soap were cut into a large portion. So the fourth step is the continuous bar from the extruded soap then cut, stamp, wrap and pack individually according to the intended market. So in this step, I also include the drying process. After the homogenized soap in a large portion were cut, the soap were dried first before it was stamped, wrapped and packed individually. So as we can see from the PNID of soap manufacturing, okay, on the left side is the mixer, which also known as amalgamator. Mix water, brine, alkali and oil, and then the mixture was passed through to a CSTR, the roll mill. In the reactor, the mixture will also mix with perfume and color to give a better presentation and a better scent. Okay, and then the mixture, the homogenized mixture will go through a cooling process and then will cut. The pink equipment is the plodder or extruder, plodding or extruder, which the homogenized soap were cut into a large portion and then was dried. The dried soap and then stamped on the stamping or pressing, then cut into a smaller piece of soap and then were wrapped and packed individually right before it was shipped to the market.
We're going to look at the food industry process next. For the food industry process, our group choose the ice cream manufacturing process. In the ice cream manufacturing process, they mainly have 6 main process, which is blending, the pasteurization, the homogenization, the aging, the freezing and the hardening process. First one, we look at the blending process. In the blending process, all the ingredients are selected based on the desired formation on the company. If the company want to make a secret ingredient of their ice cream, all the ingredients are mixed together to make an ice cream mix, and a high-speed mixer is used in the process. Then we move to pasteurization. In the pasteurization is the biological control of the process, which is, as we know, pasteurization is designed to kill all the bacteria that exist in the food or the mix. The pasteurization process is conducted at 69 degrees Celsius and held for 30 minutes to satisfy legal requirements. And pasteurization process also can increase the shelf life of the product. We look at the homogenization. Homogenization process forms fat emulsion by breaking down or reducing the size of fat globules The purpose of this process is to produce the thinner and more rapidly wheat mix of the ice cream. The process is taken place at the pasteurization temperature, which is 69 degrees Celsius. The benefit of the process is to produce a smooth ice cream and improve the resistance to melting. Next, after homogenization and pasteurization is done, the mix will be sent to age. The mix will be aged at least 4 hours or usually overnight to allow the time for the fat to cool down and crystallize. The product of this process is to improve the whipping quality and texture of the ice cream. And the process is conducted at insulated or refrigerated storage tank below 5 degrees Celsius. The mix is done aging. Then we look at the freezing process. The mix is drawn into a flavored tank and mixed together with the food coloring. In this process, all the flavors and coloring will be added to the ice cream to make it look and taste delicious. The freezer is jacketed by tubular heat exchanger filled with boiling refrigerant such as ammonia or freon. The mix then will be pumped into the freezer and sent to the packaging to be packaged. And lastly, we look at the hardening process. After the ice cream is done being packed, the ice cream will be put into a blast freezer. The blast freezer temperature is negative 30 degrees Celsius to negative 40 degrees Celsius. The ice cream then will be ready to be sent and sold after they've done hardening. That's all for us. Thank you very much for watching.